We're going to convert the function y equals 2x squared minus 9x plus 8 to vertex form by partial factor. First thing we're going to do is common factor the first two terms, including the leading coefficient. So we're going to common factor out a 2 and leave us with a term in here of x minus 9 halves. Now, a factor of x minus 9 halves, I should say. Now we can determine where this parabola crosses the line y equals 8 by setting the first part of this expression equal to 0. If we do that, we get x equals 0 or x equals 9 halves. We can then find the x value of the vertex, in other words the x value of the axis of symmetry, by the midway point between those 2 points. 0 plus 9 halves over 2 is the same as 9 halves divided by 2, which is 9 halves divided by 2 over 1. Invert and multiply, and we get x equals 9 fourths. That's our axis of symmetry. We plug that x value in to the function equation in either the first or second line to get the y value of the vertex. In this case, it's negative 17 over 8. What we did is we plugged in a value of 9 quarters. Now 9 quarters minus 2 times 9 quarters is, if you follow the steps, 9 halves. 9 quarters minus 9 halves, if you follow the steps, is negative 9 quarters. And that brings us to this line. If you follow the steps, 9 quarters times negative 9 halves times negative 9 quarters is negative 81 over 8. So we get negative 81 over 8 plus 8, which is negative 17 over 8, because when you have a common denominator of 8, this is your result. I'll let you focus on that fraction work a bit. Okay, so what we then are able to do is say that the y value of the vertex is negative 17 over 8, the x value of the vertex is 9 over 4, and the leading coefficient is 2. So we can state the quadratic function in the appropriate vertex form as y equals 2 times x minus 9 over 4, quantity squared, minus 17 over 8.